Okay. Yeah. Hello, good afternoon, everyone. Welcome to today's section. Sorry, I began this section quite late. Wasn't intentional, but things just came up. Okay, for today, we'll be discussing Kubeflow pipelines and components. Let me get the PowerPoint we're using. Let me share my screen first. Is this visible enough? Can you see my screen?
Yes, we can. Go on.
Okay, good. So as I said earlier, I'm discussing today Kubeflow pipelines and components. But before we can talk about Kubeflow pipelines and components, we must talk about Docker first. So the workflow for today's section, we have the first segment, talk about what is Docker image, how to build Docker images, some basic commands in Docker. We'll do a demonstration on building an image in Docker. Then our second segment, we talk about Kubeflow pipeline. What is pipeline? How do you build Kubeflow pipeline? And the techniques used in building pipelines, be it reusable components or lightweight components. Then in the last segment of our workflow, we'll run a project for machine learning using a dataset on diabetes. We'll first break down the project into different stages. Different stages. We'll have the data loading, data pre-processing, data modeling, model training, model testing, and model evaluation. And then we'll convert these images into an operand in Kubeflow, and then deploy it in the Kubeflow pipeline. Let's begin now with the first workflow, Docker. Okay, now, what is Docker? Docker image is a file that is used to execute codes in a Docker container. A container is a standard unit of software that packages up code and all its dependencies, so the application runs quickly and reliably from one computing environment to another. Now, what does this mean? Let's assume now you have, let's say, a very simple function, let's say to sum two numbers now. Let's say A is equal to 1, a variable A equals 1, B, another variable equals to 2. And you want to get maybe deploy or put this function into an image. This can be done using Docker. So Docker helps us to containerize our codes, be it on Python or any other programming language, so that code will not be compacted into an image, and this image can run in any operating system, be it a MacBook or Ubuntu or Windows. Now, irrespective of your operating system, as far as that code is not Dockerized, that is, has not been turned into a Docker image or into a container, it can run in any operating system. And there are basic steps in doing that in Docker. The steps we have first is, you write your Python script. That's the very first step. After writing your Python script, let's say to sum A plus B, then you write a Docker file. Now, a Docker file is like a declarative file in which you indicate the Python script and the command that be used to run the Python script. That defines a Docker file. And then you have to put this Python script and your Docker file into a particular directory. Now, from that directory now, you can now navigate to create your image. So we'll take a very short example now right away, and then we'll also run some commands. The very first command to run it, to build a Docker image, is to first build it, which we call Docker build. So Docker build will first try to get layers for the image that is to be built. Then after building the image, we'll run it. Now that run will tell us if the code prepared in that script is functional. If the code is not functional, it means that Docker run command will give you an error message. But if it's functional, it will output the expected result from that function. And then we'll tag the image. After tagging the image, we'll now push the image into the repository where we can always pull it to do other function, or people can reference our image in the repository to work with the code that we've containerized. Okay, let's do that right away, immediately. Can you see my command line?
No, just the slide. I think you have to stop and start sharing again.
Okay.
Yes, we can see. Okay. Let me show you this folder first. You understand what I'm trying to do now. So this folder has two examples. We have here example 1 and example 2. Under example 1, we have the Docker file, then we have the Python scripts. Okay, let me open this for you so you see.
Let me also open the Python script also. So in the Python script, I just have the print hello, welcome to Docker. That is the Python, the script, what it's telling us to do. Just print for us, welcome to Docker. And then in my Docker file, I have from my Python version, I want my code to work with Python 3.10.4 Slim Buster. This work directory is just showing us, okay, in that container, where should this work be saved? So I called it app/app. Then environment port 80. Then copy, the first copy is telling us to copy the Python script from hello.py into the second copy, app, which is now in our container. So we are copying hello.py from the Python script into app in our container. And the command here we have is Python, and then we have command hello.py showing the scripts and the command to run that script. Okay. Let's go back to the command line. Okay, so we have this now. So it's trying to build the image for us for hello. So we are done building. So let's run it now. So if you observe now, it gave us an output telling us, hello, welcome to Docker. So let's tag this image. Then my repository name, because when tagging an image, you have to show the image name and then your repository name. So for my repository, my name there is Arinze. Then image again. So we've tagged this now. Let's push it to the repository. Okay, this has been sent to repository. Let me show you this on Docker then. Can you see this?
Yes, we can.
So now we just sent just one email just now, which is called hello. This one here. So this is how you create images, and then you send the image to your repository. Like currently, I'm using Docker Desktop. That's why you can see it here now. If I go to my repository, maybe online, you see also this image also that was just put just now. Okay, let's go back to our PowerPoint. That's for the first segment. The second segment, some basic commands we have in Docker. We have command PS. That PS stands for processes. Then we have Docker RM. That is to remove an image. we have Docker RMI to remove an image based on the index number. We have Docker build, which we just saw just now. We also have Docker run, which we did a few minutes ago, and Docker tag and the rest of them. So let's come to the second segment, pipeline. Now, a pipeline is a description of a machine learning workflow, including all of its components in the workflow and how they combine in the form of graph. As I said earlier, in a machine learning project, definitely you will have at least 4 or 5 stages: the data loading, the pre-processing, the modeling, which entails the training and the testing, and then the evaluation. So now we'll try to see how we can do this now using Kubeflow. And in Kubeflow, what we do is to create the Python script such that each function has each workflow has a function. Let's say we have a function for data loading, a function for pre-processing, a function for modeling, a function for training, testing, and also evaluation. And this script will have to, let's say, link from one component or from one function to another, such that the output of a previous function will now serve as the input for a new function now. Okay. Now we have concept in Kubeflow. So we have the pipeline component. So this is a self-contained set of codes that performs one step in the ML workflow, such as data pre-processing, which I said earlier, transformation, training, and so on. It represents a step in the workflow where each component takes one or more inputs and produces one or more outputs. Then we have the graph. The graph, this is a pictorial representation in the Kubeflow pipeline of the runtime execution of the pipeline. We have the experiments. Okay, let me log into Kubeflow now, so you also see what I'm trying to explain. Right? I appreciate it better. Correct. Okay. So so you can see it here now. Experiment, pipeline, runs, recurrent runs, artifact, and the rest of them. So let's go back to the PowerPoint. So the graph is a pictorial representation in the Kubeflow pipeline UI of runtime execution of a pipeline. Experiment, this is a workspace where different configuration of pipelines can be tried. It's usually used to organize runs into logical groups. A step, this is an execution of one of the components in a pipeline. Now, in building a pipeline, we have two basic procedures.
we have the first one, which we call the reusable component. That is building your pipeline using reusable components. Now, in this case now, we prepare each stage of the workflow into a directory that will contain the Python script for that stage and the Docker file for that stage. And that will be done for all the stages of that project. So first, write out the Python script for all the stages of the workflow. 2, write out the Docker file for the different stages. 3, build Docker image for each component and push to the repository. 4, turn function into container operand using the DSL. 5, define the DSL pipeline. Then 6, compile the component into a YAML file. And the last step becomes run the YAML file in Kubeflow. So we'll run these procedures now, and then let's see how we'll go about that. So let's go to Jupyter Notebook. Okay, now this is a script now in Notebook that contains all the stages. Data loading is this, data preprocessing, data modeling, model testing, model evaluation. Now this part now accounts for just the basic stages of the experiment. Let's run this now. So we can begin with our that has gone. Then data modeling run. Okay. Model testing run. Okay. Model evaluation run. So this is the result from the project based on a notebook. But now we want to convert this thing into a pipeline. So these different stages now would that be in a folder? Let's go to that folder. Here we have usable components. Okay, now if you observe now, I have here data loading, data modeling, data preprocessing, model evaluation, model testing. Now, because I ran that script just now, I've gotten these files. These files have been produced now, data.pkl and the rest of them. So, we said that when running pipeline, you have to go to your directory that has, okay, let me open one of them. I see something here now. Now I have the script for data loading and the Docker file for data loading together. For modeling, I have the same thing, the script for modeling and Docker file for modeling. Likewise, this also preprocessing, the same thing, the Docker file for that particular stage and the Python script for that particular stage. So let's do these images now on Docker. Delete this one's here. So confuse ourselves.
components. So the first stage is data loading. Okay, this has this has a Docker file, and then this has also the Python script. So let's build the image for that. Docker build dash tag. Then we have to now pick a name for it now. So I have data download. That has been built. The next will be to run it. Okay, that is done. The next will be to tag it. We have to get the image name, which is data download. Then the repository name. / the image name now. That has been tagged. So let's push it now to the repository. Docker push repository name / image name. So let's view it now in Docker. So you can see it now. We sent the first stage now, which is data download. So this will be done also for all the stages now. So I have so the next stage now will be data pre-processing. Then we'll just run the commands we used previously to build the first stage. Then Docker run. What did I use here? Pre-process. Okay. Then we'll tag it then. Then we push. So let's confirm that in our repository then. So that having sent already now, what we have here. Okay. The next will be data modeling. Docker run. Then Docker tag. Docker push. So we'll go to the fourth stage now, which is data model test. Then we run it. Then tag.
Then push. Then the last stage now, evaluation. Then Docker tag. Then the last, push it. So let's check our repository to see. So we have the 5 of them now. Download is ready, pre-process is ready, model train is ready, test is ready, and likewise model evaluation is ready. So now we'll build these images now into in Docker. So let's come back to our notebook. So after building these images now, the next thing will be converting these images into operand. And to do that, Kubeflow has a module which is KFP. Now this KFP will assist us in converting a Docker image into a container operand. It's like converting image into containers. So what do we do now? We define each stage now. We have def for data download operand. This would take the name of this image now will be called ingest data, and the image to use for this container will be the one we deployed earlier, which is arrange02/data download. The Python script that was already copied to our Docker, and this is the command that we use to run the scripts. This will apply to all the stages: data download, pre-process, model train, model test, and model evaluation. So let me run this now. Okay.
Yes, converting containers to operand. And here, this is the last stage of the work. In this case, now we're trying to arrange how the pipeline, the flow it should follow. That is from what stage to what stage. And we use the DSL.pipeline to do that. So we have to define our pipeline, which because this data is on diabetes, tend to classify if a patient is diabetic or not. So I tagged it dev classification pipeline. The PVC is the persistent volume for our work. And then we have the download task, which will work with the download operand. We have the pre-processing task, which will work with the pre-processing operand that we did earlier here at this stage, down to the very last. And then we now have to combine all these stages from the very first stage to the very last stage into a YAML file, because what will run in Kubeflow will be a YAML file that will show all these processes. Let's run this now. Okay, this is done. So let's review the YAML file that was produced now. Classification pipeline. Here's the YAML file for the work we just did just now. This is the name of the pipeline, diabetes selection pipeline, ingest data, test, train, pre-process, and the rest of them all to the very last. So it will take all the stages involved in the work. So let's go to the pipeline now. So in pipeline, since we're here now, to run that YAML file, we have to create an experiment. Okay, let's create an experiment. I'll call it classification. Classification pipeline. Classification pipeline. So let's get our YAML file. Classification pipeline. Run name, let's call it classification. Classification. Diabetes. The same thing also. So I'm coming. Okay, let's wait for this to build. Okay, the first stage has been built. Stage persistent volume claim. This is like the volume that will be used for this pipeline. Let's wait for it. Okay, that has been built now. The ingest data pipeline is ready. Okay. So pre-process has been done. Now model training. Okay. The last stage, the fourth stage now. Okay. And the last. complete. So what we have here, we've built a pipeline from the very first stage, ingest data, pre-process, model training, model testing, and then evaluation. So we've seen how we started from the notebook in Jupyter. Then we took each stage into a Python script and built an image for each script using Docker. And then we converted each Docker image into an operand. After that, we coupled the operands for the different stages into a pipeline, and we got our YAML file, which we use here now to run on Kubeflow. Here on Kubeflow, we had to first create an experiment, which we saw earlier, created a pipeline, and then the last was the run, which we've seen just now. So what you have here now, this diagram showing the different stages, how they're linked, is called a graph, which I told you earlier. Graph is a pictorial representation in the Kubeflow pipeline UI of the runtime execution of a pipeline. So if you have any questions for regarding the processes we've taken for this demonstration, I can attend to them now. Christian.
Yeah, I can hear you. Thank you for that wonderful session. Well, if anybody has any question, drop it in the chat on Zoom or YouTube. I'm happy to give you an answer. I have like 5 minutes for questions and answers. Just drop it in the chat.
Yeah, one thing interns should try to explore this period is to see how they can maybe on their own try to run the labs in the material. Yeah, you might be wondering how will you run Kubeflow in your local? Yeah, actually, to run Kubeflow in your local, you need a minimum of 16 GB. By the minimum requirement to run Kubeflow. But then you can subscribe to Azure for free credits. So with the free credit, you can get a VM that can run this for you. And you can run the installations for Kubernetes service and Kubeflow, and then run your labs there. With that will give you a hands-on experience on how to build Docker images and then convert images to operand and operands to pipeline in Kubeflow. Yeah. So we can explore that for hands-on using Azure.
All right. Well, in the absence of no question, I guess they all understood it clearly. And thank you, Arinze. That was a wonderful presentation. I guess this is where we'll draw the curtain and call it a day. Thank you, everybody, for joining those on YouTube. We'll see you again next time. Have a wonderful weekend. Bye for now.
Thank you for your time.